this video, I'm going to show you how to improve the performance of the receiver section of your transceiver. And what's more, it won't cost you anything at all. For the demonstration of this, I'm going to use the Yaesu FT710 transceiver. It's a cracking transceiver. I've had mine now for about 9 months. It works extremely well. I reckon it's the best value on the market at the moment, particularly if you buy the field version. It's got really good performance. Front end is superb. It's an SDR transceiver. It's the first Yaesu fully SDR transceiver that they've made, believe it or not. And if you bother to look at the Sherwood engineering site, you'll find that it's right at the top there in performance. So in terms of value for money, I think it's superb. I don't think it's any better on the market at the moment than the FT710 if you're on a budget. So let's take a look at how you can improve the performance of your receiver. You don't necessarily have to have an FT710. You can use the principle that I'm going to cover, or the principles I'm going to cover, on most modern transceivers. So let's get it underway and see if we can improve the performance of your receiver section of your transceiver. Now, the first improvement you can make, and this applies to every transceiver, almost every transceiver, the speaker on a transceiver, loudspeaker, is placed on the top panel, so it's firing up. That's not where you want the audio to fire. You want it to be projected towards you. Ideally, the speaker would be on the front panel, but generally speaking, it's not possible because there's not room, so it's placed on the top, facing upwards. What you want to do is to have some sort, well, you can do it with your hand actually, just put your hand behind the speaker, you'll hear the audio come forward. But if you come up with some sort of device that sits on top of your transceiver and deflects the audio forwards, make a big difference. You can do it with a simple cardboard box actually, cardboard box, cut out the front and take the bottom off, and that projects the audio forwards. It makes a tremendous difference, so give that a try. So I've come up into the radio room and I'm going to take you through the changes or the adjustments I've made to the FT710 HF transceiver, and I'm sure a lot of the adjustments I make you can make on your own transceiver. And one of the things, by the way, that attracted me to the FT710 was the fact that you can plug in an external monitor, which is a sort of I think it's probably a first for a budget class transceiver. And if, like me, your eyes start to get a little bit weak, then the large display is quite useful. And I'll try and use that display to demonstrate what I've been doing, or what I think you should try doing as well. Here's the display of my FT710. You'll notice that I've got the RF attenuator switched off, and I have got the preamp switched off. Now, it's important that when you're on particularly the lower bands and you're using an outside aerial, you probably don't need the preamp. The test is switch the preamp on and see if it makes an improvement. It may seem to make an improvement, but it may simply just amplify everything, including the noise, and there's no benefit there. So switch the preamp off and then put it on again and see if there's any difference. Probably on the lower bands, you certainly won't need it on at all. You'll probably only need it on the higher bands, maybe 15 meters, 12 meters, and 10 meters. But you see here, I've got no noise floor showing. You don't want any wriggly lines there at the bottom, which is the noise, because there's no point in having it. Now, let's turn the audio gain up.
You said 7.3, yeah, that's about right. Okay, thanks, David. Absolutely nothing from Henry there now. Okay.
Now I've got the RF gain control fully up at the moment, and you can hear the noise. What you really want to do is to turn the RF gain control back until the S meter rests at roughly the signal strength of the station. So I'm going to rotate the RF gain control back now. Now I've set it at sort of about S8, S9, and that improves the signal to noise ratio quite a lot.
Name is David, a location about 10 miles northwest of Swindon. So anyway, back to you, Ray.
We tend to get a quieter noise. Now there is QSB at the moment, so it's not a fair test, but you get the idea. Rotate the RF gain control until it's the same strength as the signal. You don't need any more RF gain control on that, otherwise you'll just bring up the noise. Now it also makes hunting out signals a bit less fatiguing. I've got the RF gain control fully up. I'm going to back it off to around about about S7-ish, something like that, as against that. Now if I back it off like that, it makes hunting out signals a bit more pleasurable.
Unfortunately, because it's going to be too hot.
You can see you get far less noise when you're tuning.
That's great to know. Back to you, Jeff.
Now what about selectivity? You know, a typical SSB passband is around about 2.7, 2.8 kilohertz. That tends to be a passband which gives reasonable signal reproduction. Sounds, reasonably nice without having too much bandwidth and letting all the other stations come in as well. So selectivity is important for rejecting adjacent channel noise, but also as you reduce the selectivity, as you narrow the bandwidth down, so you actually improve the signal to noise ratio. So that's something that's worth looking at. So let's now have a look at selectivity. Now I've set this radio up at the moment. It's got a 2.7 kilohertz bandwidth, which sounds okay, but I can switch to a preset 2.1. Now I've now set it to 2.1. It's still perfectly readable, not so nice to listen to, I grant you. We're losing some of the low frequencies, and we can probably improve on that. So that's 2.1 kilohertz, that's 2.7. I'm now at 2 kilohertz, and I think about sort of 1900 kilohertz is about the minimum for speech quality, but we are losing a bit of intelligibility. And as we go up in selectivity or increase selectivity, so it improves this 3 kilohertz there.
In the American elections, but we'll wait and see.
Now the thing is, of course, you've got to adjust the selectivity to suit band conditions. Now I found that when you narrow the selectivity, the signal sounds a bit thin, but there's a way you can actually improve that without opening up the selectivity. Let me just show you. Now I've got a signal here which I'm set to 2.1 kilohertz. Unfortunately, conditions aren't very good at the moment, but I can actually get an improvement by using the shift. I've now shifted LF, given it a little bit more low frequency, and it doesn't sound too bad. Let's tune it back in again.
Working sort of Japan in the morning
Right.
and the west coast of the States every afternoon, but didn't last too long, but it was nice while it lasted. And
When you put some negative shift in with narrow frequency, it improves the quality, I think. If I go to 0 shift, it's not so good, it's a bit thin. So try taking the shift down, LF. Now we've got 2.1 kilohertz and a negative shift, which actually sounds pretty good. And that gives us a much, turn this down a bit, that gives us a much better signal to noise ratio. So play about with your shift as well as your bandwidth. Now, these settings are personal settings, personal to you, and it all depends, of course, on whether you're using the internal speaker of the radio or an external speaker of the radio, or indeed your hearing, because as we get older, we tend to lose the high frequencies. And what would sound okay to somebody that's 35 or 40 years old may not sound very nice to somebody that's twice the age. I know. So do bear in mind that these settings I've given you are not cast in stone. They are settings that I've found I prefer, but hopefully it will encourage you to also explore. And basically, some of these settings, you'll get a better idea how to achieve them if you read the user manual. Now, I know we're all guilty, aren't we, of switching on the radio and not using the user manual. But if you've got time and if you've got the inclination, it's worth getting down to reading the manual that covers the adjustment of the IF shift and the selectivity, how you do it, because it pays dividends. And you know, when band conditions are poor as they are at the moment, or from day to day they vary, but conditions are not particularly good at the moment, it's an opportune time to actually sit down, open the manual or play about with the radio and adjust these settings and see how you can improve. But I'm sure if you haven't played around with these settings before, you will actually be pleasantly surprised. You can actually narrow down the selectivity, reduce the noise and get better copy from no investment at all, just sitting down and getting the adjustments right. It pays dividends. Now finally, there's one other area of the radio, or the Yaesu FT710, that you can actually fiddle around with, because you can actually change the actual receiver's audio reproduction. You've got a bass, a mid-range and treble controls. Some of the other radios have got even more than that. They've got sort of, it's got like an equalization, EQ control. These 710, it's budget, but it's got bass, treble, bass, mid-range and treble. If you've got a modern radio, check the user manual, because you may find it hidden about there. It's not the most obvious control to hit you in the face when you first switch it on and play around with it. But if you look in the user manual, you may well find that you can actually change the audio response of the radio. We're not talking about the filtering now, the what was traditionally the IF filtering, bandpass filtering. We're talking about the actual audio stage itself. So let me show you on the FT710 how you can change it, and then it's worth looking in your handbook for your radio to see if you've got that option as well. Now on the Yaesu FT710, you select the menu, click on radio settings, and we've got AF treble, AF mid and AF bass, and we've got separate settings for SSB, AM and FM, and this basically affects the actual audio response of the audio amplifier in the radio. And if we click on the treble, we can then hear the difference.
Maybe 18 years ago, Cyril, I built my own porch, at the front, and it's timber and it's brick at the bottom.
You can probably hear the difference there.
Very, very well known.
We can adjust the treble control quite extensively.
So he come in round.
The mid-range is even more effective.
Just renewed it all, I had actually renewed a lot of it. Anyway, he come up with a price it's only a small porch.
I don't think you'll hear too much difference on the bass.
I suppose 3 foot out.
I can hear a difference on the bass, but you probably can't hear it. But those controls there are quite useful, and certainly if you've got a hearing problem, then that may well improve things for you. I hope that will encourage you to experiment with your receiver, but there are other aspects to making copy on receiver more comfortable. You've got a noise reduction, or a lot of transceivers have got a noise reduction system on the transceiver, and the FT710 is no exception. That's got a noise reduction button on there, and it works extremely well. And most of these noise reduction units on transceivers are adjustable. Very often you just simply hold the noise reduction button in for 2 or 3 seconds, and it will take you into a menu which will allow you to select different levels.
To do a couple of things before the weekend really starts. So with that, I'll love you and leave you. Have a good weekend, chaps. I'll have a look around
One thing I would mention is when you use the noise reduction circuit, also back off the RF gain somewhat, because that will also help the noise reduction unit to work better. Unfortunately, noise reduction is noise reduction. It doesn't uncover signals that you can't hear. What noise reduction does is it differentiates between noise and the signal you're trying to listen to, and it improves the signal to noise ratio. In other words, it's intelligent enough to recognise what's noise, reduce that, but allow the signal to come through that you're trying to listen to. If that signal is below the level of noise, then unfortunately a noise reduction system doesn't uncover it. The only system that is capable of doing that is something like the MFJ unit that I think is now out of production. But basically what that does, that has a local aerial bit of wire that you plug in, or a whip somewhere, and that picks up the local noise, which might be caused by all sorts of things, noisy power supplies or the next door neighbours, whatever. And it feeds out of phase with the main aerial. It's also picking up the noise and therefore cancels that noise out and will actually uncover a signal. But that unit's not available now, and there are other units that do the similar thing. But it's very difficult, generally speaking, to remove noise in a device in your station to uncover signals. You can use a loop. A loop's a very good antenna actually. A loop is inherently, the small magnetic loops are inherently low noise devices, and very often if you've got a separate receiver input, antenna input, and you use that or plug that magnetic loop in, you'll find that very often you get better reception with the magnetic loop than your main antenna. You use your main antenna to transmit on, but you use the loop to receive on. That works quite well. There's also something called RM noise reduction. That's an internet AI based system, and what you do is you feed your signal into your computer, send it out to the RM noise platform, and it applies artificial intelligence to reduce the noise. I haven't used it myself, but apparently it's quite good. There is a bit of a time delay. I think it's only around about 0.2 a second, so it's neither here nor there. That's one way of doing it. Another way of doing it, of course, is to use one of the internet-based SDR receivers. There's plenty of those about now, and you can use that to receive on. In other words, you're actually receiving a signal on a remote receiver, which hopefully is fairly quiet, and you're transmitting on your main aerial. The downside of that is there is a bit of a delay, but again, it's a very short delay. It's neither here nor there. It's probably about 0.2, 0.3 of a second. The only downside of that is, of course, because you're receiving on a different antenna, you actually don't know what the true strength of the signal is that you're transmitting. In other words, if we work on a reciprocal basis, that if you can hear a station and you're running the same power as he is, you can work him. But if you're receiving on a remote antenna, it may well be that you can hear him well on the remote antenna, but you wouldn't be able to hear him very well on your own antenna, even without noise. So there's not a reciprocity, if that's the right word, situation there. But a lot of stations do use remote receivers, and I've heard them, it's on 40 meters, and it works quite well. You obviously don't want to use a remote receiver that's hundreds or thousands of miles away, because that's a bit of a pointless exercise really, unless you want to see how strong your signal is. So that's another option. BHI, a British manufacturer, makes some excellent noise reduction units that are external to your receiver. They are probably the best reasonably priced noise reduction units available. Graham Somerville runs the company. He's been running it for many, many years. He's got some excellent units, so if you're looking for a noise reduction unit, you haven't got one in your transceiver, or you want something that's perhaps a little bit better, look at the BHI products, and we do those on our website. I think basically it's an interesting exercise to see what your receiver is just capable of. So many times we switch on the receiver and we think, oh, the band's not particularly good, there's nothing much around, we switch it off again. And I'm sure there's quite a few stations that have never explored the receiver capabilities. They switch the transceiver on, they work a few stations, and that's it, and they're maybe quite happy like that. But it's an interesting exercise to actually see what your receiver is capable of, and perhaps make yourself a cup of coffee and look at the handbook. You might find some aspects or some options there you didn't even know existed. There we are. So that's my take on receiver performance and how you can actually improve your receiver capability without spending any money. As usual, thank you for your support on this channel, it's much appreciated. I'm sitting out in the sunshine, 30 degrees centigrade, and it's the first time we've had 30 degrees for ages, so it's really pleasant. And the only thing I'm pretty sure of is it won't last, but there we are. We haven't had a particularly good summer here in the UK. I hope where you are it's a lot better, although I think in parts of west side of America it's been really, really hot, so perhaps we're not doing too badly really. In the meantime, thanks for your support on the channel, much appreciated. Don't forget to press the subscribe button, and as usual I look forward to seeing you in the next video. Bye for now.